Today we're going to graph the cosecant and secant functions, and they're going to look kind of weird, all right? So first thing to point out is remember back to when we talked about the ratios. Cosecant is r over y. So what's going to happen is every time you see a y coordinate that's 0, you're going to have 0 on the bottom of your fraction. It's going to be undefined, okay? So if you look at those angles of 0 and pi, there's going to be an asymptote at 0 and at pi, because there's a 0 on the bottom. There's a 0 on the bottom of a fraction, so you're going to be undefined there. So if you continue around the circle, you're going to have an asymptote at 2 pi, keep going, 3 pi, and so on and so on and so on. Going backwards, we'd have one at negative pi, negative 2 pi, negative 3 pi. Okay, so let's check out what this looks like. I'm going to go over to Desmos real quick, and that is what our cosecant function is going to look like. Notice this is a secant, this is a cosecant. Okay, secant, cosecant. They look pretty much the same except for a shift. It looks kind of weird. It kind of looks like almost like a bunch of parabolas. That's not quite the right relationship, the right pattern, but I know it kind of looks like that. So keep that in mind, all right? So think about that. Now, how are we going to graph this by hand? By hand, what you'd have to do is remember that cosecant is the reciprocal of the sine function. So really what we're going to have to do is go back and remember how to draw a sine function, okay? And a sine function had an amplitude. This had an amplitude of 1 and a period of 2 pi. And so when we drew that, we marked off pi, cut it in half again. And then when we drew this function, we looked at the y numbers on the circle, and the first y number was 0. And then the next y number, pi over 2, gave me 1. And pi gave me 0. And 3 pi over 2 gave me negative 1. And then back to 2 pi is back to 0. So there's my sine wave, okay? I'm going to continue that pattern. I'm using x's here to remind myself that that's not really the graph. I don't really care about my graph of a sine function. I'm looking for a graph of a cosecant function. Dotted line to remind me that I don't really care about this. Okay, so a cosecant graph is going to have something to do with a sine graph. It's the reciprocal, so that's what we have to do. Now go back here to Desmos, okay? So check it out when I add in a sine graph. Y equals sine, x. Okay, so check it out. Look how the sine wave and the cosecant graphs are related. They're touching at the tips of those humps. So all we have to do here to finish this graph, if we're graphing by hand, is take a hump and flip it. Try really hard to touch the tip. It should touch one point right there. It should be tangent to that hump. So is this continuous? Well, no. It's not continuous. They're asymptotes. X intercepts everywhere it crosses the x-axis. Well, the graph that I'm doing, the cosecant graph, doesn't cross the x-axis. You're looking at the sine wave, all right? The sine wave crosses, but my graph here that I wanted to draw for cosecant is blue, and that doesn't cross the x-axis, so there are none. Let's put amplitude over here. The period is 2 pi. The amplitude, technically there is no amplitude. Amplitude is like a maximum, indicates how high this graph goes, and since a cosecant graph is going to go up forever, we would say there's no maximum, so there's no amplitude. Symmetry, this is symmetric with respect to the origin. Odd and odd functions have this property where we can pull out the negative. Okay. let's look at secant. Secant's basically the same thing, okay, except this time you're looking at where x is 0. Anywhere x is 0 is going to have an asymptote. So like, for instance, pi over 2, and 3 pi over 2, and 5 pi over 2, negative pi over 2, negative 3 pi over 2, negative 5 pi over 2. Okay, we are flipping a cosine graph because secant is the reciprocal of cosine. So remember how to do a cosine. Cosine had a period of 2 pi as well. Cut it in half and half again. So we're looking at these points. Okay, cosine curve though, cosine curve started at 1. That was your first x number at 1. And then it goes to 0 at pi over 2. Plug in pi, you get negative 1. Plug in 3 pi over 2, you get 0. And plug in 2 pi, you get back to 1. So that's my cosine curve. Continuing the pattern, we can finish off the cosine wave. Now again, don't be confused because that's not part of my graph. That's not part of my answer. That's just kind of my setup, how I'm going to figure out where this answer is. The secant wave, try to touch that point. The secant wave is going to flip these humps, approach your asymptotes. Like so. Continuous, no, because there's asymptotes. X-intercepts, none. Period is 2 pi. Amplitude, none. Symmetry, this one is symmetric with respect to the y-axis. Remember how we told that, okay? I said the y-axis is like my body, okay? And so you're looking at the arms like there. The arms go up, and that's how you tell it's an even function. Okay, symmetric with respect to the y-axis and all that. So it's an even function. Whoops. And an even function has the property where the negative just vanishes. So then let's look at the steps real quick. The guidelines are basically this. You're going to draw a sine or cosine wave and then flip the humps, okay? So step 1, ignore the shifting and graph the related reciprocal function. That's just saying graph the sine or cosine wave. So remember, the period is 2 pi over b for sine and cosine. So the period would be 2 pi over b for cosecant and secant. The only ones that are different are tangent and cotangent. So anyway, we're going to graph the sines. We'll have to shift. We'll draw the asymptotes, draw the U-shapes, and all of that. You get the idea. Example 6, we're going to graph this secant function. So what I want to do is I want to just kind of pretend like it's a cosine. Secant is the reciprocal of cosine. So I'm going to look at what this would look like if it was y equals 2 cosine 1/2 x. All right, so just treat it like a cosine. We already know how to do a cosine. Cosine has an amplitude, or this cosine has an amplitude of 2. And the period is 2 pi over b, which in this case is 1/2. 2 pi divided by 1/2. You multiply by the reciprocal, you're going to get 4 pi. Okay, so a period of 4 pi and an amplitude of 2. Now, since my graph doesn't go to 4 pi, bless you, I'm just going to extend my graph so that it does go to 4 pi. Otherwise, you'd have to change the scale, and that's fine too if you want to do that. I think it's easier just to extend it out to 4 pi. So what we do is we mark that period of 4 pi, we cut it in half, and half again. That's where my marks are going to be for my cosine wave. It always goes back to the circle. And if you think about it, the first cosine number is going to be 1. It's basically like if you plugged in a 0 right here. Okay, if you plugged in this 0, angle of 0 in for the cosine, you're going to have cosine of 1/2 times 0. That's cosine of 0, and cosine of 0 is 1. But then you have to multiply it by our amplitude number of 2. So our graph is going to start here at 2. When we plug in the next angle of pi, the next green tick mark, into this function, you have to multiply by 1/2, and 1/2 times pi takes me to pi over 2 up here. And so that cosine is going to be 0 times 2 is still 0. Plug in 2 pi, you're going to get negative 1 times 2 is negative 2. Plug in 3 pi is 0. Plug in 4 pi, it's 1 times 2, right there. So I would probably do all of my dots at once, and I would draw a dotted line through there. Make a dotted line, or make it light or something. Make it different colors if you want. Something to show that this is not actually my answer. This is kind of my guide for my answer. Okay? So that's the cosine wave that this secant wave is going to be based off of. Now you want to identify your asymptotes, and that's going to be everywhere where there's an x-intercept right there. Notice it's the middle of the cosine wave. Okay? But those values are going to put zeros on the bottom of a fraction, and so therefore we're undefined at those values, and we're going to have asymptotes. And so if you can get this far, it's really kind of simple, because you just take your humps and you flip the humps. Try your best to touch right at that point. And that's it. Now we've drawn a secant curve. After all of that, though, keep in mind that the answer is the color blue. Question? Okay. Number 7, we got a cosecant wave. Okay, so cosecant you're going to treat like a sine. But also we have a shift, notice. Okay, this shift says to the right, pi over 2. So what I'm going to do is I'm going to ignore the shifting. We'll get that in later. And I'm going to treat this thing like a sine graph. And so let's look at the non-shifted sine curve. 3/2 sine x. I can always shift it later, and then I can flip it for my cosecant graph. Okay? So for my sine wave will have an amplitude of 3/2, or 1.5. And the period would be 2 pi over 1, which is 2 pi. And so how I would graph that is I would go, here's 2 pi, cut it in half, and half again. And then you can graph those points for the sine wave. Okay, the sine wave, sine starts at 0. We're going to go up to 1.5 and 0 and negative 1.5 and 0. A lot of this is based off of, I've just got memorized what a sine curve looks like. Okay, a sine curve looks like hump goes up, hump goes down. It starts at 0. Got some of these things memorized, but it also goes back to that same circle from before. All right, the first sine number was this 0 right here, and the second sine number was this 1, and of course you're going to multiply by the 1.5 in the front. Okay, now I'm not going to draw that curve through there because I have to shift everything to the right by pi over 2. So I'll shift everything to the right by pi over 2, and then I'll draw the rest of the dots and stuff. Okay, so let's go ahead and shift that to the right by pi over 2. Now notice on this graph, pi over 2 is worth 2 tick marks. So I'm going to shift that to the right, pi over 2, and pi over 2, pi over 2, pi over 2, pi over 2. Okay, so that's my shifted sine curve. I can go ahead and finish the pattern. And I would draw a dotted line through there. And there's my shifted sine wave. But now I need to flip everything. I need to look at the intercepts, okay? So to find the intercepts, you got to find the middle points of the curve. Sometimes that's tricky when you've shifted it, especially when you've shifted it up and over. But there are going to be asymptotes at those middle points. And then, of course, we can flip the humps to complete our curve. Number 8, determine an equation for the graph. All right, so now we're working backwards. We're looking at a picture and we're trying to come up with the equation. So when you look at this one, what functions do you think about? Tangent, might be a tangent, might be a cotangent, right? It's one or the other, okay? So remember what you've memorized. You memorized that a tangent went through 0 and was increasing, and a cotangent did not go through 0 and was decreasing. Okay, so you should have memorized those two things, tangent, cotangent. And so you look at this graph, and it's almost like it's a combination of the two, because it goes through 0, but it's decreasing, okay? So what that means is, well, what'd you say? A flip tangent, that's a great idea, okay? If we just flip a tangent, that's going to be a good way to deal with that, or a good way to look at that, okay? So look at it this way. We think this is going to be a flipped tangent graph, okay? Now, we just have to take care of the A number and the period, okay? So notice this dot is at +2, and it goes to 0 and to -2. So you ought to be able to tell me the A number. The A number is 2, right? Okay, so I'm going to stick a 2 right there. Now, the period is a little bit harder to come by, but the period is this distance right here, from left to right. And so for a tangent graph, period is pi over b, okay? Anybody know this distance right here from -pi/2 to +pi/2? That's pi, right? So if you compare that statement right there, you ought to be able to tell me that b equals, what does b equal? Well, it's got to be 1, right? B has to equal 1, and so I know there's a 1 right there. There's no shifting, and so that's it. That's my answer. Y equals -2 tangent x. There are other ways to answer this question. Maybe you saw it as a cotangent with a shift. You could do it that way, but I think it's going to be easier to do these questions if we try to stay away from shifting if possible. So that's why I like what we did with the flipped tangent. Okay, we look at this next one. This one looks like a cotangent to me, okay? It doesn't go through the origin. It's decreasing. I feel like this one's a cotangent. So look at the A number. See how this is 1, 0, -1. A must equal 1. And then the period from here to here, well, that's just got to be pi/2, right? So if the period of a tangent or a cotangent is pi/b, and in this case it's pi/2, then b must equal 2, right? And so there would be a 2 right there. Your answer, y equals cotangent 2x. A C, well, obviously this is either a secant or a cosecant, right? And so in order to determine which one it is, I would try to figure out which reciprocal function I'm looking at. And so think about this. Look at that red curve and try to think about that red curve, okay? Kind of looks like a sine wave to me, okay? But if you look at it another way, it kind of looks like a cosine wave, okay? We want to try to make this as easy on us as possible, I think, okay? And so consider this. If this were a sine wave would have to start at 0 like this, and apparently this one would be shifted up and over. So there would be a double shift on a sine wave. Shift up and left, okay? The other possibility is if I just, if I just took this and shifted it up 1, this looks like a cosine wave that's shifted up 1, okay? So the red to me looks like it's a cosine wave that's shifted up 1. Okay, so think about that. Cosine wave shifted up 1. So then consider the amplitude and the period. Amplitude works like this. Look at the middle of your cosine wave and think about how far it is to the maximum or to the minimum. Can you tell me what A must be? A must be 1 because it's only 1 off of the middle. All right, so I know A is 1. That's this number in the front here. Now, for the period has to be from the start of your curve to the end of your curve right here. So essentially, you have to go from negative pi over 2 to 3 pi over 2. Okay? From negative pi over 2 to 3 pi over 2. There's a couple of different ways to think about this, but maybe the easiest is to act like you started at 0. If you started at 0 and went to 3 pi over 2, but then just added another pi over 2 on the end of that, anybody tell me what that is? Period is 2 pi. Okay, that's right. So if the formula says the period is 2 pi over b, and we just figured out that the period of this one is 2 pi, then that means b must equal 1, and that goes right there. Okay? Now, keep in mind, answer the question. The question's not talking about the cosine wave. It's talking about that reciprocal function, and the reciprocal function is going to be secant, so my answer is going to be y equals secant x plus 1. Now, there are other ways of doing this. You could think of it as a sine wave that's been shifted to the left, and so it could be a cosecant if you figure it, but you're going to have to think about more shifting.